The UUM School of Computing processes student records, financial data, and administrative files daily. Moving this data between buildings means passing it through the public internet, an untrusted infrastructure where any node along the path could intercept the transmission. To solve this, we use a virtual private network. Tunneling encapsulates packets inside a protective secondary packet, creating a secure pipe across the internet. This tunnel ensures confidentiality by encrypting data, integrity by preventing alteration, and authentication by verifying device identities. We apply this technology in two ways. A remote access VPN secures a single remote user, such as a student connecting from home. A site-to-site VPN connects entire network infrastructures, linking a main campus router directly to a branch office router. Protecting multi-campus operations requires a structural, network-to-network VPN backbone, isolating private traffic from the public internet. To build these site-to-site tunnels, we rely on IPsec, a framework of protocols and security services. This architecture utilizes security associations to define parameters, IK to manage the handshake, encryption algorithms like AES to scramble data, and hashing algorithms like SHA to verify integrity. When configuring IPsec, you must choose your protocol. The authentication header, or AH, verifies identity and prevents tampering, but provides zero encryption. To scramble the payload, you must use the encapsulating security payload, or ESP, which adds encryption alongside authentication and integrity. ESP operates in two modes. Transport mode encrypts only the data payload, leaving the original source and destination IP addresses visible. Site-to-site VPNs use tunnel mode, which encrypts the entire original packet and wraps it in a new IP header, hiding the original routing information. Setting up this tunnel involves two steps through the Internet Key Exchange, or IK. In Phase 1, routers authenticate each other to establish a secure management channel. In Phase 2, they negotiate the specific IPsec parameters to build the actual data tunnel. Let's test this. If a branch needs to hide its original IP addresses and encrypt the payload, which IPsec mode and protocol must it use? You need tunnel mode to hide the IPs and ESP to encrypt the payload. Meticulous IPsec configuration cloaks an organization's network architecture from external observers, preventing unauthorized parties from mapping the internal infrastructure. Translating this IPsec architecture into a working configuration requires following a specific logical sequence on the router's command line interface. First, you define interesting traffic using an access control list. This instructs the router exactly which data requires VPN protection, isolating sensitive branch traffic from standard internet data. Next, you define the security rules. You configure IKey policies for the management handshake and IPsec transform sets to dictate which encryption and hashing algorithms the router must apply to that traffic. Finally, the crypto map binds the traffic identification to the security rules. You apply this completed map directly to the router's outgoing interface to activate the protection. Success in network engineering relies on this sequential logic, identifying the target, defining the armor, and binding them together at the gateway. IPsec VPNs provide enterprise-grade security over public networks at a fraction of the cost of purchasing dedicated physical lease lines. This logic applies globally to corporate branch connectivity, remote workforces, and the secure transmission of sensitive financial or medical data. To summarize, a VPN provides confidentiality, integrity, and authentication through encapsulation. Within the IPsec suite, ESP provides the necessary encryption, while tunnel mode hides the routing headers for site-to-site links. Implementation follows a strict flow. Define the traffic, configure the handshake, set the encryption rules, and apply the crypto map. The internet remains an untrusted environment. Meticulous configuration of these protocols is the primary defense protecting an organization's most valuable assets.